The next step is just to check how good is this propensity ranking model doing. So remember what we did was rank order the propensities according from higher to lowest. And basically what we would like to do if we were working on a problem like this would be to take a look at those customers likely to drop. So let's do something really quick here. Write, let's export it to Excel so we can look at it a little better. So I'm just gonna go ahead and get these in a CSV file and open it in Excel so that we can go ahead and look at it better. So we have all of these customers with their likelihoods or propensities to churn from the bank. We have in our validation data set, we have, let's say, 2,701 data points. Now remember, what we would like to do in real life is rank order those customers that are likely to drop and basically do something about the customers that have a very high likelihood of dropping. So let's say that we want to select the top 200 observations. In this case, it would be here, and basically do something about these customers. These are their IDs. Maybe give them an offer of a gift card of, let's say, 200 so that they can use it something, but that's going to take some funds and some um, some resources to do that. More importantly, these customers with very high likelihood of churning did actually not churn. So in our validation dataset, we can look at how good is this model in actually selecting those customers likely to drop. But there is a bunch of them that actually did not. So the question is, we would really not like to do this and spend resources on customers who are not really going to drop. So we have to evaluate how this propensity ranking model is doing. How much better than random is it um, doing in actually predicting the customers likely to drop by giving it a higher propensity. So this is what propensity ranking does. And we have to actually look at a couple of things, and that's one of them is looking at the lift. Lift is how better than random are we doing. So if we wanted to give an offer, let's say give customers $200 gift card randomly, as opposed to just selecting it based on the propensities, how much better are we doing than random in sending the gift cards to those customers likely to drop? So this is where we are going with the lift, what the lift and the lift charts are giving us. So we have to do, to get the lifts, we have to use the carrot package. And again, there's other ways to do this, but this is probably the easiest way. We want to make sure that our variables are coded correctly. So the exited flag is, first of all, is it a factor? We kind of coded it in the last data set, but we want to make sure that we have, so we have that here as well. So we are going to take a look at the structure. And yes, we have it coded as a factor. The next thing we want to do is take a look at the levels. Is the reference level the 1? So we using our base level to be the level that we are interested in predicting the ones as opposed to the zeros. So we want to take a look at the levels here and how is it set up. So we want to do sorted propensities, $, and that is basically the exited. And we can see that the first level is the 0, so we want to change that before doing lift chart. So let's do these. Let's call it sorted propensities. So we're just going to override it, and first of all, what we want to do is that we want to re-level the variable. and basically by setting the reference level to 1. So now if we check back, 1 is selected as our base level.